This video is going to take us through some examples that involve expanded octets. The first example that we're going to go through is sulfur tetrafluoride, or SF4. So let's begin. Sulfur is in group 6, that'll be 6 valence electrons. The fluorine is in group 7, and there are 4 of those, that'll give us 28 more. And so then we have a total of 34 valence electrons. The single atom sulfur is the one that's going to be going in the center. And so our skeletal structure will involve 4 bonds to the fluorines. That uses up 8 valence electrons, leaving me with 26. We always start arranging the extra electrons around the outside atoms first, and we do the central atom last. And so for the fluorines, in order to get them up to an octet, they're going to need 6 more dots, or 6 more valence electrons. And that's because we already have one bond which has 2 electrons, and so the 6 dots will bring us up to the total of 8. So if 4 fluorines each need 6 more electrons, that'll use up 24 of our remaining electrons, and that leaves us with 2 left over. Now as we turn our attention to the central atom, we notice that sulfur is already surrounded by an octet of electrons. We already have 8 electrons around there. But we can't just make those 2 extra electrons disappear, otherwise that would violate the law of conservation of mass. So we can take a look at the last step, which is extra electrons are placed on the central atom, and that's where they're going to go. Now, this is going to give sulfur what's known as an expanded octet. Sulfur is now surrounded by 10 valence electrons. As we look through the octet rule and the exceptions to that, we found out that you can have an expanded octet as long as you have a central atom that is in period 3 or beyond. So sulfur is in period 3, it is the central atom, and so this structure is going to be allowed, and that's the final structure. Now let's erase this, and we're going to do one more example. So our last example is going to be phosphorus pentachloride, or PCl5. Phosphorus is in group 5, chlorine is in group 7, but there are 5 of those, so that'll give us 35 more electrons. So we have 40 total valence electrons to work with and put into my diagram. We'll place phosphorus in the center since there is only 1 of those. And let's distribute that around so that we have 5 bonds to the different chlorines. The 5 bonds will use up 10 electrons, leaving me with 30 left over. Each of the chlorines is going to need to have 6 valence electrons added to get up to 8. And as you can see, since I have just used up the remaining 30 electrons, there is no electrons left over for the central atom. We turn our attention to the central atom and we notice that it already is surrounded by 10 valence electrons. So that's going to be an expanded octet for phosphorus. And that's going to be allowed as long as that central atom phosphorus is in the 3rd period or beyond, and phosphorus is in the 3rd period. So here's our final structure.